Okay, in this video, we're going to talk about residuals. So first, I think it's important for us to see what's happening here. So what I've done is I've drawn a little picture here. These gray data points, those are actual data points. So that comes from actual values. And then from those actual values, we are going to find the difference between the model and the actual value. So we've got this model, and the model goes pretty much through the data. That's what we've been taught. The model goes through the data. But really, there's just one model that best fits that. So I'm going to draw those lines, those distances below the line in blue, and then the distances above the line in purple or pink. So we've got these two pinks and this blue. If I were to add the distances of this pink and this pink, that distance, that sum of distances would equal the sum of distances of those segments below the line. There's only one segment here that's below the line. It's this blue one. Whatever this distance is, it's going to be equal to this distance plus this distance. That's how you get that perfect model that goes through the data. And sometimes when it goes through the data, it actually hits on an actual data point. In which case, the residual value here would be 0 because there's no difference between the actual output and the model's output. Now, when there is a difference between those values, in each one of these other three cases, the residual is going to be the actual value minus the model. So whatever that model is, that's your predicted value. The actual minus the predicted is your residual. And the residual can tell us some interesting things. Right here, we're going to look at this table. This table represents the weight of a baby in kilograms after a given number of months that it's been born. So after a number of months after birth, they weigh the baby. So when the baby's born, a month later, 2 months later, 3 months later, 4 months later. So T represents the number of months since birth. Number of months after birth. I've run out of room, so we'll write it up here. After birth, number of months. And then this is the weight of the baby in kilograms. We want to use the regression capabilities of our calculator to find a linear model in the form y equals a plus bx. That's important. Y equals a plus bx. For the weight of this particular baby, now it says X months after birth, but we're already given a table that says T is our input, so I'm going to change that to T months after birth. Go ahead and press pause. Find the linear model using the stat button of your calculator and come back to check your answer. Okay, if you're back after pausing, yay you, we're going to check your answer. If you never paused and you're just waiting for the answer to be given to you, oof, you know better. Okay, you can only learn by doing yourself. WT is equal to 3.34 because they want the constant to come first, plus 0.8x. So that right there is our model that we can use to predict. And when we predict within the data, it's called interpolation. When we predict outside the data, it's called extrapolation. Let's use this model to predict the weight of a baby 2.5 months after birth. So what I'm going to do is I am going to put in a 2.5 in for T. So I get 3.34 plus 0.8 times 2.5. When I multiply and add those two numbers together, I get about actually exactly 5.34 kilograms, because these values didn't keep going forever, so I didn't have to round because I don't have any irrational numbers happening. We are good, 5.34 kilograms. Now, C says the actual weight of this baby 2.5 months after birth was 5.5 kilograms. The actual weight 2.5 months in, 2.5 months into the data is what I meant by into the data. 2.5 into the data is a 5.5. That's actual. However, we want to use the model. So actual is equal to 5.5 kilograms. But if we want to do our prediction, that's using the model, we got 5.34 kilograms. The residual is going to equal the actual minus the predicted. So our residual is equal to 5.5 minus 5.34. And when I do that subtraction, I get 0.16. Meaning the actual was higher than the predicted. So positive 0.16. Therefore, the model underestimated. The model underestimated the weight of the baby. The weight of the baby. And that's underestimated. I'm going to highlight underestimated because the residual value was positive. If the residual value is negative, then the model will overestimate. Model overestimates when the residual is negative and underestimates when the residual is positive. Okay, in the next video, we are going to use a residual plot to check the appropriateness of a model.